All right, so today we're going to again try to finalize a little bit of understanding of when is a function continuous. So basically recall that in order for a function f to be continuous at a point, it must be the case that the limit of that function as x approaches that value is actually equal to that function at that value. It's often referred to as three-part definition or three-part checklist of continuity. So here they are again. Your value, your actual point must be defined and exist. Your limit must exist, and then they must equal each other. Essentially, the three quantities must all be the same finite number. So finite is important here because you can't have an infinite limit. That doesn't count because that's a limit that technically does not exist. So your left-hand limit has to equal your right-hand limit, and then that together makes your general limit, and then that equals your value, okay? So let's go ahead and we're going to complete the table below by looking at this graph specifically, okay? So basically, we're looking at the left-hand limit, the right-hand limit, and then the actual function at that point. I'm actually going to do the far right column first because that's easiest to me. So if I actually find f of -2, I'm actually finding the point there. I'm going to -2, and I'm saying, oh, that's undefined, or I'll put D and E because that'll fit easier here. So automatically I could say that this is the function is not continuous at -2. So let's see, f of 1 would be, again, undefined. F of 2 would be 2, because when I actually go to 2 on my graph, I have a point. It's actually at 2. And then f of 4 would be the point that's actually at 4, so that would be at 1. All right, now let's look at my left-hand limits and my right-hand limits. So going back to -2, as I approach -2 from the left-hand side and the right-hand side, that both those go to infinity. As I approach 1 from the left-hand side and the right-hand side, those both go to 1. As I approach 2 from the left-hand side, I get 2, but from the right-hand side, I get 4. And then last but not least, as I approach 4 from the left-hand side, I get 2, and from the right-hand side, I get 2. Lovely. So now what it wants to do is basically use the information from that table to indicate the reason or reasons for the discontinuity at each x equals c by placing a check mark in the column that applies. So for example, when I'm looking at x equals -2, I ran into a couple of things. So first and foremost, my value did not exist, and my limit, my general limit, wasn't a finite number. So for number 1 and number 2 were both the reasons that the function did not exist there. My limit wasn't an actual number, and then my point wasn't an actual number. All right, let's look at x equals 1. Oh, oh, and we can also, obviously 3 would also be true then. So a check mark for either column 1 or column 2 will necessarily result in a check mark for column 3, because then that part would not be possible as well. And so if I'm looking at x equals 1, I can do the same thing. So my limit does exist. My general limit doesn't exist. So I can't check column 1 because my limit is a finite number, but my actual function at that point is not. Therefore, my general limit cannot equal my function at that point. All right, let's look at x equals 2. So my left-hand limit and my right-hand limit both exist, but they're not the same, which means my general limit is not a finite number. And then f of c is the first time, this is the first time we actually do get a finite number, so I can't check this column. And then last but not least, then obviously, if I have a finite number, an infinite number, then they can't equal each other. And then last but not least, at x equals 4, my limit exists and my point exists, so I can't check either of the first columns, but my limit does not equal what my point is. So this is, again, just us kind of going through and comparing the discontinuities in a graph to what happens to their limits and the actual points, and then the reason that it wouldn't be continuous. Remember, we're always checking this 3-step process along the way, okay? So it's just a quick review lesson on that, so go ahead and try some practice with it.